I was really tempted to squish this with 16.3 and just call it a day, but I thought mine as well, since they have 16.5, I don't want to confuse students. So given a vector field in 3 dimensions, I mean, I know our book separates between the 2 and the 3 dimensions. I kind of combined those in the previous section, so we don't have to worry about doing 2 separate sections. So this section is going to be very short. Suppose the given vector field has 3 components, P, Q, and R, in which their partial derivative exists, and the curl of F and the curl of F and the divergence of F are determined or defined by, we know the curl already, that's del crossed with F, and the divergence is del dotted with F. So keep in mind how this works. This right here is a vector. This right here is a scalar. Don't mix those two. We need all of this for 16.8. So, can you find the curl of F? Well, okay. Curl of F is del crossed with F. That's much easier to remember than you memorizing a formula. Partial with respect to X, partial with, since it's 2 dimensions. Since it depends on 2 variables, you know what I mean. The partial with respect to X, that's e to the y cosine of X, minus the partial with respect to Y, negative, that is X the sine of Y. Done deal. And if I take the divergence of F, something we need later on, that's del dotted with F, that is the partial with respect to X, the partial with respect to Y, dotted with X cosine of Y. And I know you're wondering about something. I will elaborate in a minute. How come that's not a vector? The partial with respect to X, that is the cosine of Y, plus the partial with respect to Y, that's e to the Y sine of X. Remember, if you're dealing with 2 dimensions, then the determinant is always a constant. For you to get a vector, you need it to be 3-dimensional or more. That says on R3, not on R2. But I want to show R2 and how it works. So, and since you were asking, here it is. What if I'm looking at the following problem? Again, if I want to find the curl of F, that is, and it would be a wise thing to actually write them out. And that would be the I component X minus 2Z, the J component Y minus 0, and the K component 2x minus 2x e to the x. There it is, a vector. Done. And if I want to go for divergence of F, that is del dotted with F, that is the partial with respect to X, the partial with respect to Y, the partial with respect to Z. And I'm going to dot that with 2xy e to the x, x squared plus y squared plus z squared, and xy. Okay. We have all the space we need. And that would be the partial with respect to x, the product rule, derivative of the first times the second plus the first times derivative of the second, plus the partial with respect to y, 2y plus the partial with respect to z, whatever that value is, and I'm done. Let me edge. And a couple of pointers. If you have a vector field on R3, P, Q, and R have continuous second partial derivative, then the divergence of the curl is always 0. And you would know that F is a conservative vector field if and only if the curl of F is 0. I'm missing more. And that's it for this section.